So this is about mass versus weight. I think up until now you probably have used these synonymously, but in physics class we don't use them synonymously. Okay, mass is how much stuff you have. Okay, it's measured in kilograms or grams, right? And you can be weightless, but you can't be massless. Okay, objects cannot be massless. They always have a certain amount of mass, no matter where they are, right? Weight is the force. It's the force of gravity. Okay, so weight is going to be measured in newtons or pounds or other units of force. So let's take a look at this. Okay, they are different things. Okay, so just be careful, right? Mass is literally, it's related to stoichiometry, right? Which I love. Okay, it's the amount of stuff you have. It's related to protons, neutrons, electrons. And this is the triumph of modern science. If you tell me the mass of copper you have with a presumed isotopic abundance, I can tell you how many protons there are there, how many neutrons. This is amazing. Okay, mass is measured in kilograms. Okay. It's also measured in grams. The English unit of mass is, by the way, not a pound. That's actually a unit of weight. That's a unit of force, like pounds of thrust. Okay, the English unit is a slug. Okay, now here's a good question, right? Which one's bigger, a kilogram or a slug? Now, before you Google it, obviously you can just Google this, right? Let me give you these clues. Okay, a kilogram is the amount of mass you have if, when you exert 1 Newton of force, it causes an acceleration of 1 meter per second squared. Okay, a slug is the amount of stuff you have if, when you exert a pound of force, an lb of force, if you exert a pound of force, it causes an acceleration of 1 foot per second squared. Okay, now let's think about this. Okay, a pound is actually 4.45 newtons. And a meter per second squared is actually 3.281 feet per second squared, right? So think about a slug, right? You're exerting 4.45 times more force, and it's accelerating at 1/3 the rate, roughly, right? So that should give you a clue. One of them's bigger than the other, right? So the talented and gifted, if you're just talented, you could tell me which one's larger based on that, right? If you're talented and gifted, you could tell me what the conversion factor is from slugs to kilograms, given these two things, right? Anyway, you could think about that. You might not have ever worried about that before now, but there it is, right? It is a measure of inertia. So the more mass you have, the more inertia you have, and it's not zero in space. Okay, if I have a kilogram of steel, I have a kilogram of steel in space. It's going to react with the same number of milliliters of sulfuric acid to create hydrogen gas and whatever the salt is, ferrous sulfate or whatever it is, right? Okay, so if you have a kilogram of steel, you've got a kilogram of steel. Okay. Now here, okay, look at this. Let's check this out. Look at this animation. Look, it's like over here. Ooh, the weight. See, it's like gravity, so it goes down. I am really teaching you. Okay, so weight is the force of gravity acting on an object. It is measured in newtons. This will be our unit, right? If you're dying to know what this one is, this is Cgs Units. Okay, so it's what a dyne is, the force exerted on a gram, which is like a paper clip, where it accelerates at 1 centimeter per second, right? And then the English unit of force is pounds. Okay, and this is what we're accustomed to. So when we say, I say I weigh 168.4 pounds, I'm saying that's the force of gravity on me, right? That's indirectly related to the amount of slugs of my mass, which is interesting, right? You can be weightless. So if there is no gravitational field, you are weightless. Okay. And then here's a demo calculation, right? The only formula they've got in the data packet is that G is F over M, and this is buried way in the like the field theory part of it. Okay. Basically, here's the force, right? The weight of an object is equal to the mass times gravity, right? So the force of gravity, if I just solve this for this, right, is equal to the mass times the gravity. So G is actually the gravitational field strength, and we sort of lied to you, right? We told you that G was 9.81 meters per second squared, but G really is, on the surface of the Earth, is 9.81 newtons per kilogram. Okay, that's what it really is. Okay, it's just that back in chapter 2, you would have gone, what's a Newton, what's a kilogram, right? But now we're ready for it, right? So this is really our force. If that's the force of gravity, right, it's just m times g. So for example, if you have a mass of 4 kilograms, right, your weight would be 4 times 9.81. So this is my mass, is 4 kilograms, right? But my weight would be 4 times 9.81, 4 times 9. So it'd be 39.24 newtons. Okay. Now, you can also think about this in terms of F equals ma, right? If you drop an object, it accelerates at 9.81 meters per second squared, and so the force acting on it must be F equals ma, right? And the mass is what the mass is. The a is the acceleration of gravity here, right? The acceleration of gravity. You could do that, right? Okay. So the example you have on your sheet there, you have 5 kilograms, right? So let's do that, right? If we have 5 kilograms, what is the weight? So this is the mass, right? The mass is 5 kilograms. What is the weight? And again, this is as hard as force of gravity is m times g. Okay, so the force of gravity is going to be, which is the weight. The force of gravity is the weight. 5 times 9.81. And this is kilograms. This is 9.81 newtons per kilogram. So notice that kilograms cancels. You end up with newtons. So 5 times 9.81 is 49.05. And that's newtons. Okay, so be very careful. It has a mass of 5 kilograms. That is its mass. That's how much stuff it has. If you go into space, you still have that much mass. Okay, it doesn't go to 0, right? But because we're in a gravitational field here near the surface of the Earth, it has a weight as well near the surface of the Earth, and that weight is in newtons, right? It's 49.05 newtons. That is the force of gravity, okay? They're different things in physics land. So just don't embarrass me, okay? Refer to them properly.